Okay, so what I'm going to talk about is unnesting JavaScript callbacks and method declarations. The unnested callbacks is something I started doing a while ago, and just the other week, Trevor Norris had spoken about the performance implications, and he basically showed the same pattern, so I thought it was worth sharing. So any of the performance stuff in here is completely from Trevor, it's not mine, but he's obviously really smart, and yeah, I thought it was worth sharing. So in terms of agenda, what I'm going to do is walk through callbacks, the traditional nested callback, unnested callback, and then method declarations with nested and unnested. If you're interested in running any of the code, you can see the GitHub URL down here. It's all documented, each of the files, and it's just git clone and then run the code. Okay, so this is the traditional callback. I mean, pretty much all the sample code on the internet always shows callbacks because it's expedient. The problem with this is several-fold. Is if you go one layer down, it's fine, but if you start having multiple nesting, right, you end up in a condition which eventually creates callback hell. Also, it indents your code too much; it becomes less readable, and whatever other horrible things can happen from it. But also, you can see that it's basically what Trevor had shown is about 8 nested callbacks are responding in about 290 milliseconds. And if you're interested in his performance stuff, you can probably talk to him because he's better than I am. And this is effectively the same code. What he showed pseudocode. I'm just showing you one of my examples. But from his, he went from was almost 300 milliseconds down to about 114 milliseconds. So that's fairly substantial in terms of performance improvement. You'll also notice it becomes infinitely more readable because the code, effectively flows from top to bottom, right? We start off, we have our fs read file. The callback and read files, read file 1 comes over here. We handle our data, right? And then we call our read file 2. And effectively, it creates a nice sequence of callbacks from top to bottom. Easy for experienced people to read, easy for unexperienced people to read. And yeah, that's basically it. It's fairly straightforward. Sure.
So the only difference is that instead of having the nested callback, you actually, using anonymous function, you actually go like this.
Yeah, exactly. So instead of using an anonymous function, you do a named function, and then you take the named function and you unnest it.
How can I have something?
Sorry, no, go ahead.
Oh, it seemed like that they're exactly the same execution.
It's not.
It's parallel. So it's not parallel, it's in serial, right?
Yeah, it's still in series, but the performance difference is fairly heavy. And the sort of paraphrase, this was part of a Node talk that Trevor Norris had given where he was talking about Node internals. And he was talking about some of the internal performance optimizations that happen, and without sort of repeating everything that he said, effectively the Node runtime can optimize this a hell of a lot better.
So anonymous functions don't get the same optimization as named function? Is that the key gist of it?
It had something to be blunt about it. I don't really want to paraphrase it. To be candid, his talk was outside my capability.
Okay.
So it's probably worth actually watching his original video.
What was the talk? Who was the person?
Trevor
Norris.
Trevor Norris. He's one of the Node core guys, also on Mozilla.
Okay.
Which version of Node?
That wasn't mentioned.
I think it's valid for 10. I don't know about other versions. The Trevor Norris spoke at Node Day, which was, I think, last Friday, and I missed it. I was out of town, which I was bummed, but the talk is posted and there is video online. I'll put the info up on the GitHub repo for this talk.
Yeah, the short version, to give you guys sort of the paraphrase, is that the Node runtime, what it does is things that are inlineable. Once it gets down to the machine level, it's going to start to inline a lot of your functions. So functions are called with the same parameters in the same order with the same data type. Once it sees that, it actually starts to optimize it and it then inlines your functions. And that's pretty much where your performance boost comes from. A few side notes on that also is don't put comments inside the function. You want to wrap your functions with comments above or below because there are limit sizes on both code plus comments. So funny little stuff like that. And then also you want to try and define functions near usage.
So this is all VX specific. It probably has nothing to do with Node.
Honestly, I don't know. Again, that's outside my area of expertise.
Node is V8, so.
Not.
And then, so what I was showing here also is, so, then once you unnest, you do have to worry about how you're going to pass data. With the first example, what I did is I passed it by attaching properties to my final callback. And that way I never use globals. So you see, like, I need file content 1. It's actually, you can't see it because it's off the page. But eventually there's a final callback where we're writing file content 1 and file content 2. But what I'm doing here is attaching those properties. And then leveraging hoisting because, you know, write file 3, which is a callback, is actually defined further down. And then, of course, other options you can do is exact same code, but what I'm doing is just leveraging file globals. So, you know, in Node, if you're using a module, it would be like a module global. So it's not horrible, but just defining variables at the top. And then when I get my callback, setting file content 1 equal to my data. So that's obviously, I'm defining my variables above and outside of function scope so that you can share. And there's a bunch of other things you can do. You can do like anonymous functions with, you can basically wrap your name functions and anonymous functions as closures. So you get a lot of the same benefits. There's the, you know, any way you want to slice and dice data passively, you can do with it.
So this would only work if the data arrives as one big chunk. What if the data is streaming?
Honestly, I haven't even bothered with streams yet. It's on my like to-do list. Haven't bothered. You're asking me all the questions and things I haven't done. But yeah, so basically this was a problem that I ran into. I just needed a way to organize my code, and like I said, there was a talk that sort of showed that it's also performant. But streams, no, I haven't handled that yet. Okay, so kind of the benefits that I've seen of unnesting the callbacks. Personally, I find the code easier to read. I think it's your mileage may vary. But I think in large teams, the advantage of it is eventually you're going to have to unnest. Because if you have 8 levels or 10 levels or 12 levels deep, you have to unnest. So you either have to have a coding standard that says, well, once you hit 3 levels, unnest. And then every new developer in your team has to learn that, well, when I have 2 levels, I can nest, but 3 levels or 4, I need to unnest. With this, you pretty much have a standard of just unnest from the beginning. For people on your team that are new to Node, it basically helps prevent callback hell. There's a good quote on solving callback hell that somebody said is the best way not to end up in callback hell is just not go there in the first place. And that helps you get there. I think the flow of code is really easy to read because it's just top down, it's linear, it's kind of like any other language that people know except that you're wrapping in function scope. You know, other than that, it's kind of the same. Performance is better. You know, you're talking about hundreds of milliseconds, which does matter. You know, it's going to affect your users. And then the last one, if you go on the GitHub URL, named functions have a huge benefit in terms of debugging. You know, as your code gets bigger and bigger and bigger, with named functions, you're giving information to the Node runtime so that when there's an error, it doesn't just spit out like a file number. It actually can say, well, you know, this file at this function. And that can get pretty beneficial as your code gets larger and nastier and hairier.
And why not use the async module to do the same thing?
Yeah, sure. I was actually going to say that. You can certainly use async. I think in this case, personally, I wouldn't. I think anytime you add abstractions, you know, it's just, why add an abstraction for something like this where you don't really need it? You know, async is certainly good. I think if you have like running things in parallel, async is certainly good. You know, and you certainly can. I just think you're accomplishing the same thing without a library.
It's still a good idea to pass name functions into async too, for the same reason
Totally.
you get these good error messages.
Yep. Yeah.
I'm still bothered.
Sure.
So if you, I don't have the diff of the code, the first version, the second version, one next to each other. So are you saying that the first one, it was doing, this is doing obviously sequential.
Yeah, everything is sequential, but what you're seeing here is like, we're doing fs read file, and then we're doing an anonymous function, which is actually defined here inside of the first one.
Yeah, so.
And we get another anonymous, which is again defined inside. Yeah.
Okay.
Which, you know, if you start carrying this out further and further, this is where you start seeing JavaScript code just arc way far to the right.
The other one is the same.
No, this one's different. What we did is, you can see here is instead of embedding the function as a anonymous, what we're doing is just passing a name, and then we're defining the function all the way to the left and hoisting it.
But still, first, before the second function is executed, they need to have read the file.
Yes.
Then it's going to read the other file, and then it's putting them together.
Yeah, the flow is exactly the same.
It's not that it's reading the two files at the same time.
No,
Because
no.
That would ever expect having like a performance increase.
Yeah, the performance increases from the node internals. I would highly recommend check out Trevor's talk. He'll get into like the details of it.
I just tweeted out the link to the
Yeah.
URL.
Yeah, honestly, I'd say he's good enough that if he says there's a performance difference, I kind of trust him. Okay, cool. Any other questions? Sorry, to build on what you said about even with async, you want to use name functions. Once you go to named functions, even with async, there's a lot of benefits because you can start doing things like conditionally include or not include functions within your async calls. You want to do things like anything that's going to happen in non-asynchronously. So for example, if you have a bunch of if clauses, you don't want to throw those inside a function and then throw that function inside an async call because you're just basically killing all your asynchronicity. Because you'll end up in a race condition, which very often performance just clobbers it. Okay. Nested method declarations. This one's 100% stolen from Trevor's talk. So basically, we're defining a constructor function. So function cat. Cat has two methods: getName and setName. And you can see in the first one, we're doing what a lot of people do is nesting the method declarations inside cat, and then just var meows equals new cat, and give it a name, and then we're logging it. This one is a nano optimization. Literally, it's response time is 280 nanoseconds. So nanoseconds, there's a billion of them per second. And then the huge performance gain you get is going down to 7 nanoseconds with unnesting. The short version here is the way I would get into it is in terms of performance. If you're not like Yahoo scale or any of the companies of that scale nature, performance-wise, this gives you no benefit. You're talking about 1% CPU at scale, like really large scale. Sure.
Well, if you're instantiating a lot of cats, though, then things add up.
Yeah.
They can, yeah.
That's what you're asking.
Yeah.
If you only have one, then sure, it doesn't matter. But
Yeah. Totally. I like it because again, it gets into the whole you don't have to start having insane rules everywhere. Like this is when we nest, this is when we don't nest, and, which I find even with my own coding, I don't like. It's just easier to always say, okay, unnest everything. It's easy to read. There are a lot of people starting to code with unnesting all the time. So if you read like the Yeoman source, they've already started unnesting for whatever reason. Maybe it's for performance, maybe it's for readability, but there's more people doing it. I like it because if you're going to unnest your, unnest your callbacks, it makes sense to also unnest method declarations.
This is definitely practically different because as he was saying, it's not just a performance; it's also a memory kind of optimization. Because if you start having a lot of cats,
Yeah.
you see growing because you instance more and more functions.
Yep. Exactly. So basically the same thing. Unnesting, pretty straightforward. And that's it. Only other thing, one of the projects I'm working on starting up a new company called Exponential. Right now I need feedback on it. So if you guys if you have any free 30 minutes, it's really easy to install. And npm install, you create an account. And if you have any feedback, you can either tweet at me or email me. And I don't need just good feedback, I mean anything. So, any final questions on this stuff?
Not really a question, but I wonder how much of these optimizations become obsolete as the V8 engine matures.
I don't think these will become obsolete. The way the prototype inheritance and the way it's been optimized in V8, that's going to be in there for quite a while. There's new class things coming out in the new versions of ES, but we won't see optimizations for that for quite a while.
And I think some of it also just gets into coding style, right? What is going to be the standard routine and
I think what you showed with the callbacks is something that V8 could potentially optimize to get the first version down. But yeah, this code is doing something different than the
It makes
previous
sense
one.
that a compiler should be able to figure that out.
Thank you.